Now we come to the actual part. We know about the history of the telescope, how this was being made, and who were the people behind it. Now we'll just see how, why we call it a telescope and how does it work. So here you can see the telescope which we see in the modern times, which we are all familiar with. It's a Newtonian telescope. But let's see how does the whole thing works. And we all know that an optical telescope works in the optical window of the electromagnetic spectrum. So we'll just have to see how the light behave in different mediums. So we all know that light travels at the speed of 3 lakh kilometers per second, and it always travels in a straight line. But then how do we control it? Just like if there's a kid on the block and if he is hyperactive, then how do we control him or her to do the work? That's what we are going to do with the light. There are three basic ways to control the light. The first one is to block it. For example, if the light is coming towards you and you put something between you and the light source, then you are blocking the light. The perfect example of this is the solar eclipse, which we see, the total solar eclipse and the partial one also, where we are blocking the light. In the total solar eclipse, we are blocking the light completely. In terms of the annular solar eclipse, we are not completely blocking it out. And in case of the lunar eclipse, we are seeing while the earth is blocking the light, we are seeing the effect on the other object, that is the moon. And up there on the moon, you can see Apollo 16 astronaut over there casting a shadow on the moon. So just below the astronaut over there, if there is any object over there, he won't be able to see the sun simply because it has been blocked by an astronaut. Second thing is to reflect the light. That means change the path of the light. We have a day-to-day example of seeing ourselves in the mirror, or let's say the rear view mirror of the car, in which we see the vehicles which are behind the car. We can see those. So the light coming to the mirror does not go through the mirror, gets reflected back and comes back to your eye, and that's how you are able to see that object over there. In this example over there, you see, when you have a mirror over there, a flat mirror, then there's a butterfly over there, and the light from the butterfly comes to the mirror, gets reflected back, comes to your eye, and then you see the object up there in the mirror itself. And the third way is to bend the light by passing it through a medium. Here you see that naughty kid over there sitting and looking at the camera with a small piece of glass, which is not the flat glass. The glass is bent. It's a curved glass which is more thicker in the center and thinner at the edges, what we call a convex lens. And that's how the light comes from one end of the lens, goes back, goes through it and gets focused on something else. And you all must have tried the burning of paper with the magnifying glass by focusing the light of the sun onto the paper, or let's say on a dry leaf or someone else's hand also. Just try to burn the hand just to feel the heat. So these are the examples of bending the light through a medium. And here you can see, if I have water over there, then there's a submarine over there. We see the submarine slightly in the shallow waters because of the bending of the light in simple terms of optics. I'm not going to do the high tech or that part of the optics which takes you away from this lecture, and you just switch on to another of the websites. So we'll just see how does the refraction at the surface of water works. And then we can either, with the light we can either block it, reflect it, or bend it. Now once we go back to the Hans Lippershey's lab, where those Dutch kids were playing with the lenses, they were actually playing with the light and they were trying to see what happens to the light. Now in their case, they were doing something with the lenses, And in this picture you can see there's a magnifying glass over there which helps you to read the small numbers over there. So lens is a kind of a device which controls the way the light works. In this basic example we can see, as I told you, convex lens is thinner at the edges and thicker at the center. So that means the light from infinity, which is coming in the straight line in the left hand side of the picture, gets focused to one point where we call it a focus, and the whole of the light gets focused there, and you see the object over there. And on the right hand side of the picture you see the light coming from the infinity and being focused in this animation on one of the points. In case of the convex lenses, the light gets focused on one point. In case of the negative lenses or the concave lenses, which is thinner at the center and the thicker at the edges, the light diverges when it passes through the lens. So it is never going to be focused anywhere. And these kind of lenses we use normally when we have some of us who can't read objects which are very far away, they are seen as blurry images. So we use this kind of a lens to correct the eyesight. And then how do these things get magnified in the convex lens? You can see in the ray diagram over there. It's a very simple ray diagram in which the object is between the focus of the lens and the lens itself. So anything which is between the within the focal length, that will get an image which is magnified, and it's a virtual image. You cannot actually it's not a real image in which you can have it on a screen. Now when we use a convex lens as a magnifier, we get to see that object, but that object has to be between the focus of the lens and the lens itself. But all the objects in the sky, they are not between the focus of the lens and the lens, so they are far away at infinity. So there we have to use something which we call the combination of lenses. That means you have two pairs of lenses, in which one is acting as an aperture and one is main objective. The other one is working as the eyepiece with which we see the magnified image over there. That's what we call the refractor telescope, in which you can see the light from the right hand side comes down